Hello everybody and welcome to this week's Pisa Presents. Today we're going to be examining a relatively common mineral, but still one that surprisingly I've found very few people actually collect or know that much about. So today we're going to be looking at kyanite. Now, what is kyanite first of all? It's an aluminum silicate, that formula to be exact. It is what's called a mesosilicate, which is what we'll see right here. So basically, if you think of this format right here, so these are octahedrons and tetrahedrons. These are basically the shapes that these molecules take that comprise the mineral formula. So back to this, just to remind you what it is. Now, the octahedra are aluminum, and the silicas are the tetrahedra. Now, with how they bond like that, it forms chains. Long chains that sometimes go a little bit crooked here and there, but still, all together, typically it results in, well, that blades. Probably the most famous characteristic of kyanite is that for the most part it's found with these long bladed crystals. There's very commonly it is intense blue color, absolutely gorgeous color. It's actually one of my favorite minerals. Now, overall, it has triclinic crystals because, I mean, they may look like very long blades, but still, when you look at them closely, they do have an overall shape. Now, the other very key characteristic of kyanite, other than really its shape and also its color, is that it is what's called anisotropic. Now, that basically means that you can have, well, this right here. I'll just show you as an example. So, this is for hardness. You can have different hardnesses in different parts of the mineral. So, say that you pick a crystal right there, like that long one. Now, if you were to test its hardness parallel to that axis, you would find that it's 4.5 to 5. But if you were to test the hardness perpendicular to the long axis, you would find that it's 6.5 to 7. That's probably, I would think, the most characteristic defining trait of kyanite is that if you have a crystal that has these long tabular forms basically and you're scratching it, carefully keep in mind, because you don't want to mar the crystal scratching it on different sides, and if it has two different hardnesses, then, well, you probably know you have. Now, this is not kyanite. This is just an example that I got off of Shutterstock. This is a clear crystal, which, if you look at kyanite's formula, that is actually, according to the chemistry, typically what it should be. So what gives kyanite its intense blue color typically? So going back to the formula, it's good old-fashioned replacement and substitution. So the aluminum can sometimes be substituted by chromium, iron, or even manganese. The silicon can be replaced by titanium. And in cases where the aluminum can get occasional substitutions of iron, you get that lovely blue color that we all know and love from kyanite, although again, it can take other colors. Now, this is what it looks like up pretty close relatively, so you get a really good look at that color right there. Now, overall, it was named by Abraham Gottlieb Werner in 1789. The type locality, or basically the place from which the original quote-unquote specimen was found, is not known, amazingly, for something that's been around since the 1700s. You see, when Werner was doing his great study of kyanite, he was using samples from actually quite a lot of places. So it's sadly impossible, looking back now through time, to determine which specimen was really the one that he used to name it and come up with the original studies. Some sources say Austria, but that's not really proven. Now, how did he come up with the name? Well, it was originally named Zionite, which is from the Greek kyanos, which means blue. If you think of, say, cyan, that's just a root word that means blue. And it was also once known as dysthony, which means two hardnesses. You may see it called that in a couple of really old sources, or even cyanite with Cyanite. Now, this is just an example of how kyanite can take different colors. This is actually orange, which comes from manganese substitution sometimes. Things like this are typically found in some African countries, often can get that. Now, kyanite's specific gravity is 3.53 to 3.67. Here's some eye candy of a specimen with some garnets. Now, kyanite is what's called a polymorph. A polymorph is a mineral that has the same formula as others. It's basically so you can take the same chemical formula and under different physical forms, different physical conditions, really, environments, it can actually crystallize in different ways. So the other polymorphs are andalusite on the left and sillimanite on the right. So what is the difference to kyanite? Well, it all comes down to temperature and pressure. Kyanite is a high temperature polymorph of the other two. So if you look at this, not to give any geology majors any really bad flashbacks, for that I apologize, because trust me, this thing kind of makes me a little bit queasy looking at it, getting memories of petrology class. This is what's called a phase diagram, folks. This is basically something that can illustrate the differences between different polymorphs and other interrelated minerals. So if you look down at the x-axis is temperature, the y-axis is pressure, which is measured in kilobars. So the big one that's kind of like cockeyed on the upper left there, that's your kyanite. The andalusite is a little pyramid down on the bottom, and the sillimanite is the big chunk on the right. So you can see that this formula, this actual substance that we're dealing with here, it continues to be kyanite at these higher pressures over there and a pretty even range of temperatures. But you look at the other one and, well, andalusite just doesn't have that range. It has much lower temperature and much lower pressure. So you can tell by looking at a phase diagram under what conditions you'll find what mineral. Now, obviously, it's formed in metamorphic rocks subject to strong pressure. Very, very strong pressure. And kyanite is a sign of intense metamorphism deep within the earth. It's what's called an index mineral. This basically means is that it's something that sort of cues geologists and other related physical scientists into being, I have kyanite there, therefore these other related minerals must be around, therefore these other related natural resources must be around, because they know that if kyanite's there, then there is a lot of metamorphic activity in the area, and then you can deduce a couple other things that went along, not only just finding the mineral resources, but also obviously a little bit of the conditions at the time the mineral was made. Now, what is kyanite used as? Well, it's used as an abrasive. That, by the way, is black kyanite. It's used within electronics, and it's also used within refractory materials. A refractory is something that resists heat. Now, because it's formed under such high temperature and pressure conditions, kyanite is very, very heat resistant. So it's used in a lot of things, from components in your car's brakes to a lot of other very strong industrial applications that require heat resistance. So with that, here's a little bit of one of my favorite minerals, kyanite. Thank you very much, folks, and have some fun. Go out there and find yourself some rocks. Bye now.